Okay, it's we are like wrapping everything up now. I thought I'd talk about the final exam. So that's next week. Okay. So I'm still writing the exam, still tweaking it. Haven't figured everything out, but I'm thinking something. So kind of the general idea will be math slash calculation problems. Um, on content after midterm 2. Okay, and then maybe conceptual questions spanning the entire quarter. Okay, so this is kind of going to be the general theme here, and so I'll just talk about kind of the math and calculation type problems that we might encounter, and this was in writing the exam, I realized with all of these algorithm type problems, it wasn't super easy to do. So one is we're going to have a K&N classifier. And I think this is fairly easy, but I'm not sure. I provide kind of some data, some labeled data. Okay, so you'll get kind of a matrix of points. I don't know, maybe something like this: 2, 5, and 1, 4, and -1, -2, or something like this, etc., etc., etc. And then I'll provide kind of the classes. So this will be X, and this will be, I guess, Y, and I'll call this, class 1, 1, 2, 2, etc., etc., etc. Okay, and then I give a test case. Say X test is equal to, I don't know, -2, -3, or something, and then I will ask what will X be classified as for K equal to 1, K equal to 3, K equal to 5, etc., etc., etc. Okay? I think that's it for that K&N classifier there. Yeah, I guess I would need another test case or something. Okay. Does that make sense? So I just give you some training data. This will be kind of training data, and then you classify your test case. All right. I imagine you can write practice problems for this easily. This one, not too hard, right? Okay. I want to try this. can do Kmeans classifier, and I'll ask you to draw the decision boundary. We'll keep it simple and do k equals 1. This one might be a little bit hard. I'll probably make this worth only a few points. But you know, if you have something like this, how would this get classified? So I think your decision boundary would come here, and then at this point, let's see. So you kind of have to figure out what points are equidistant from these two. I don't know if that's equidistant. Something like this, right? So here and here, is that about the same? And then here it gets a little bit messy. I guess, is this point, I guess it just goes like this. Okay. Draw a decision boundary for k equals 1. Basically, you know, find the locations. Which are kind of equidistant from class A and class B. So 2 classes and something like this. You know, if I had another point here, then you would get something that looks like this. I think. If I do too many points, it gets complicated. I'll try to make it not too crazy hard, but and I'll just say this is only probably worth, I don't know, 5 points or something. Okay, but play around with the Kmeans classifier. See if you can on your computer, and I think you'll get a better sense for where decision boundaries will be drawn. Yeah. Yes, you'll have the full 3 hours. I think it's Thursday, 8 a.m. Is that right? Yeah. So it's just how it goes. Okay. Okay, so that's Kmeans. Okay, SVM. So I think the way I was trying to think of the way to do problems for this, and it's like SVM, the math behind it, the computations are like too hard to do by hand. So I think what's going to happen is I will have like something of points, okay? Okay, and then I'll and then what's going to happen is I'm going to have this, and I'll have like different boundaries drawn. Okay, so I don't know. I'm just making stuff up here, right? So one boundary might be like this, and this isn't the best example here, but you know, I might have like another boundary that goes like this or something, you know. Right, different shaped boundary things, and you'll have to try to match whether you know, is the kernel linear or kind of radial, this being the Gaussian, and is, you know, cost equal to like 1 or 100 or something, or like maybe 10, and then gamma can be like 1 or 10 or something like that, okay? And I think we had like some examples where probably should have added, maybe I'll just put a point over here. Where am I putting this? Right here, okay. So I'm gonna add this point here. And then so in some cases you'll get like something that goes like that, and then you'll have like some kind of something like this, and then you'll have I don't know, just different possible boundaries that might result for different settings of kind of the cost or the gamma. And it'll be kind of like a multiple choice match which settings I used and which boundary gets drawn. So I would say, you know, go back to your homework. So I think we had something similar in the homework, and I would say go back to the homework and then just try different sets, different kind of test cases, or not test cases, but different, I don't know, training data. I think just try generating different training data, and then try fitting different different SVM classifiers. I think all the code is already provided for you in, what was it, homework 4, okay? It's just kind of that last problem in homework 4. Just go in there, try some more, generate new training data, try out different classifiers with these different settings. And I think you'll get a better sense of kind of where these boundaries get drawn and stuff. Okay, is that all right? Or something like this? Okay. So what's that? KNN, SVM, and then, okay. All right, and then I've got a K-means problem. I think we'll do K-means by hand. This might be, and I think I'll probably just give you, like, I provide a matrix of points. You know, 1, 1, and 2, 4, and negative 3, 0, 5, or whatever, okay. Et cetera, et cetera, et cetera, okay? And then I'll also provide just arbitrary initial assignments. I guess this will be like 1, 0, 1, 0. Probably, this will probably be 6 or 7 points. Okay. And then you do, I'll test how long this takes, 1 or 2 iterations. Of K-means clustering. So that will be what? Find centroid locations, and then reassign points. And then maybe find centroid locations. So this is iteration 1 and iteration 2. Find centroid locations and then reassign points. Good. So just, you gotta, and I think you can write your own problem here by hand, okay? Just make a matrix, it'll be 2D, okay? A matrix of 2D points, about 6 or 7 of them, just some arbitrary initial assignments, and then do this, okay? And then just to kind of keep it simple, all the coordinates will be integers. I'm not going to give you like, not use our norm and get like 1.1175 or something, okay? All your points will be nicely aligned on the grid. I mean, the centroid might not be an integer, okay? It'll probably be, it'll be the mean, but at least the points themselves will be integers. So if you want to make a practice problem, don't use our norm, or if you use our norm, like round it off or something. Okay. So we have that, k-means by hand. I want to do a kernel k-means. I know this is a lot of stuff, right? But we also did a lot of stuff, and then you also have 3 hours, so not that I'm trying to make your life miserable, but okay. Kernel k-means, probably just like a small data set, either 3 or 4 points, not 6 or 7, in 2D. So like 0, 0, and 0, 1, and 3, 2, and minus 3, or something like that, okay? And then I'll provide I think this is what I'll do. I'll provide a transformation function phi. That will go probably from 2D to 3D, likely, okay? And then, I guess I'll provide the equivalent kernel function. And then you'll do, probably do one iteration of kernel k-means. Which, probably just using the kind of the transformed data. So that will be, take your 2D data, transform to 3D. Okay, I guess I'll also provide initial arbitrary assignments. Arbitrary initial assignments. Something like this, okay. Transform to 3D, find centroids in 3D. And reassign points to clusters. Okay, because I think the kernel distance function is a bit of a pain to do by hand. It's possible, but it's, even with like 4 points, it's a pain. Because you have to do like the intersection of all 4, and it's a mess. Okay, something like this. Does that make sense? Okay. And then, And then I was thinking of the EM algorithm, and this one, EM algorithm in, so I think this would be univariate Gaussian mixture. And so it'll be kind of like some points like this, okay? And then so probably something around 6 points in one dimension. And then I'll have to provide, and then we'll just say two-component mixture. And maybe I will provide, I think what I'll do is I will provide kind of initial values for mean and SD. Okay, so it'll be something like right, and then I'll say something like component 1. I'm just making up points here. So let's say this is like 1, 2, 3, 4, 5, 6, 7. Okay, and so this would be like 8, 9, and 11 or something like that. Okay, so I'm going to say component 1 has mean equal to 2 with standard sigma equal to 1. I don't know, I'm just making stuff up. Okay, and then over here we've got component 2 has mean equal to 9.5 and standard deviation equal to, I don't know, 1.5 or something, okay? And I think what I'll give you is I will provide a D-norm table. So you're used to getting the p-norm table, kind of your cumulative probability, but I'll give you the density, where the d-norm table for z-scores, right? So I'll provide a d-norm table, and then and what you will then do will we'll find the kind of probabilistic assignments of kind of points to each component, right? So this will be like a kind of a 6x2 matrix. And then you will find kind of also the updated, we'll just do mean estimates of the components. Okay, so I'll provide initial values for mean and SD and I guess n sub k, because those all factor in to. So so the probabilistic assignments of points to each component, this is Am I giving away too much by writing this? Basically a Bayes classifier. And then updated mean estimates of the components. This is kind of the, the M step in EM algorithm. Okay. And I think I'll be nice and I'll just do mean only, not the not require you to find the variance and whatnot. Okay. It gets too messy. I figure if you can do this on the mean, you can also do the variance component. Just it's a little bit more tedious or something. Okay. Is that all right? So I'll provide the initial this stuff, the data points, and then you figure out where they belong. Okay. So that's the EM algorithm. Okay, and then the last thing is PCA, and I'm not sure how to write an exam problem for PCA. I don't know what I'm going to do. What's that? Yeah, I guess that's what I'm thinking. Like I give you some points and then you figure out the covariance matrix and the eigenvectors and stuff, but like, is that all right? This is what I'm thinking, okay? And I guess just okay. This is my idea, but I have to kind of test this out to see if this is viable, okay? Like I'll give you maybe like 4 points in 2D. Okay. And then, I don't know, what will these be? 1, 1, and 2, 3, and -1, -2, and -2, -4, or something like that, okay? And then, I guess you find the principal components. But I don't know if that's too hard. Because the steps will be something like center the matrix, find covariance matrix, and then find the eigenvectors of a 2x2 matrix, which I think is a reasonable thing to ask. Like I know we haven't covered it in this class, but like do the characteristic equation, right, and solve. Okay. I don't know. And then once you find the eigenvectors, project the data onto eigenvectors. Okay, perhaps I'll ease your workload by doing one of these steps for you. Like either I'll give you the covariance matrix or I'll give you the eigenvectors of the thing, and I'll ask you to do one or the other regardless of the other answers, okay? I'll do one of these for you, okay? I'll be nice. I shouldn't make promises that I can't keep, but okay. But I'll do it. Okay, I'll do one of these steps for you. Okay, either find the covariance matrix or the eigenvectors. Okay, and then and you project the data onto the eigenvectors. Yeah. Okay. Maybe plot resulting projection. Resulting projected data. All right, and so that's that there. Okay. I think that's that. Okay, and then you guys, you'll have your conceptual questions from kind of everything. Okay. Questions? Yes. Covariance matrix of this. You can just do 1 over n. So I would just call this x-centered times x-centered. How many conceptual questions? TB, I don't know. Depends how many I can think of. They're really hard to think of. So I'll have to think. It's 3 hours, yeah. I don't know. It's a lot. Yeah. You basically, so your eigenvector, you're going to get like a W, right? And then you just multiply it by your x. So if x is or I think I have to do it the other way.
W transpose x.
W trans. That's for 1 point. X itself is n by 2, and then yeah, W. Your W is a linear combination, so this will be yeah, 2 by 1. So this will be kind of your projected data. This is 1 if this is W1. I think if you work through the homework 6, you'll see all the steps here. Okay. It's 10:37. All right, we got like 13 minutes left. Well, I was gonna do, maybe I'll save this for Friday then. I was gonna do like some neat applications. I thought was a neat application of stuff we've learned, but maybe I'll give you just my pep talk spiel about life instead. So, okay, all right. Wait, who's graduating? Yeah, look at you. All right, well, congratulations, guys. Maybe we shouldn't prematurely celebrate, but yeah, it's. I'm very excited for all of you who are graduating, and then for everyone who's not graduating. I imagine you have only 1 year left, and so graduation is not very far away, and I apologize, you might hear the same talk next year. But I guess this would be my parting advice for graduates. So I want to say a few things for those going into the workforce. Those who are, maybe some of you are interviewing for jobs, some of you have already secured jobs for after you graduate, and then some of you are going to grad school. So I have, I guess, a little bit to say for each of you, and I guess all to just kind of go along with my larger themes, which are, I always say your grades are not a reflection of who you are. as a person, okay? And I know that, you know, they play a role, and you want to do well on exams and things like that, and I understand that, but do not fear about, you know, your test scores never are a reflection of who you are. And in the same way, your job and how you do at work is also not necessarily a reflection of who you are as a person, okay? And that's not to say don't work hard, okay? Because I think wherever you end up and wherever whatever job you have, like, you should always try to do your best and be excellent at your job. But inevitably, some of you will be working, and for whatever reason, you are not enjoying your work, or you don't like your boss, or whatever it might be. And that time can be discouraging, or, you know, as you're searching for a job and things like that, it can be discouraging to get rejections or to get negative feedback and things like that. And during that, I just want to say, again, your performance at your job, or, you know, whether you're able to find a job easily or not, again, is not a reflection of who you are. It is true, a lot of your time will be spent at work, and so it's natural to feel kind of a lot of your identity and meaning to be tied to how you're doing at work. But there's 24 hours in a day, and if you're working for, let's say, 8 or 9 of them, and you sleep for another 8 or 9, there's still almost a good 25-30% of the day left over that is not necessarily work, and then you still have the weekends. And so there's a lot you can do outside of that can provide, I think, meaning and joy and a lot for you. If you love your job, then that's great, and I feel very, very blessed and lucky to have this job because I absolutely love it. But I know not everybody has a job or will find a job that they love, and I just want to say that's okay. It's okay to be in a job and to have something that you're not like super in love with. Okay, there's going to be other things in life that can bring you joy. So whether that is, you know, spending time with friends, or, you know, having a family, or any of those things, I don't want you to become depressed about I guess work or wherever it is. Okay. I want to say another thing about, like, you know, working for a boss that you don't like. Okay. Sometimes you'll be in you'll have a job, and your job is mostly okay, except for whatever reason you don't like your boss, and it's a common problem. Okay. And all I can say is just have a good attitude during all of that. You don't have to love your boss. You don't have to be friends with your boss, but always be respectful. And the thing is if your boss succeeds, if you are able to produce success for your boss, then you and your team will also succeed. And I know it can be discouraging when you feel like you've been working hard and other people around you might be getting more credit than you are, and I want to just say, even during those times, try your best to maintain a good attitude, because if you start complaining or letting your negativity start poisoning your work, then people won't want to work with you. Okay, and if people don't want to work with you, then that's just a bad position to be in. you know, I guess there's a balance though. I don't want to just say just suck it up all the time. If it's truly a toxic environment, then you've got to go. But find another place to work. But sometimes, you know, just from personal experience, I remember working for a boss that I did not like, and I allowed it to kind of influence, you know, just the quality of my work at work, and I regret that, and I regret not working harder than what I did, and it was because I just had some kind of personal disagreements with my boss, and so, you know, I regret that decision, and looking back, I think I would have liked to have, you know, been able to say I was proud of the work that I did during that time, even though, you know, I didn't get along with my boss at the time. I don't know what else to say for that. If you're going to grad school, I want to say there are times in grad school that can be extremely stressful, especially regarding writing your thesis or dissertation or whatever. And I can't emphasize this enough, especially for whenever you're a student, there's a lot of unstructured time, but you have to take care of your mental health. You know, get lots of sleep, get lots of rest, and don't allow setbacks to really bring you down. I guess that applies throughout all of your life. Get lots of sleep and take care of your mental health. But especially, I think it's a very big issue that crops up in grad school. So so please take care of yourself there. And then yeah, I'm sorry. I guess I just want to wish you guys the best wherever you guys go, whether it's at grad school or at work, and don't tie your identity and whatever just to your work or just to your schooling. You know, find things outside of that bring you joy. Invest in your relationships and invest in your friendships, because I think that's the connections that we have to other people that give us meaning in our life. So I want to say that. Okay, on Friday we'll do maybe a fun application. Maybe we'll see how it goes, and we'll see you guys then. Good luck as you guys study.